Today we're going to take a look at applications of differential equations. So let's start with my favorite problems, the Ewok problem. It's hunting season and we got to talk about how many Ewoks there's going to be to go hunting for. So we know this, that the rate of change of the number of Ewoks is directly proportional to this idea of this number 1200 minus n of t, where t is time in years. And then they give us some conditions here, right? We'll talk about those later on. Okay, so what they want me to do is find, at the end, find the number of Ewoks. So we're trying to find n of t. But the problem is, they don't give me n of t, they give me the rate of change of n of t. So they give me a derivative here. So I have to solve a derivative, so I'm going to set up a differential. So how do we do that? Well, they tell me the rate of change of the number of Ewoks is directly proportional to n of 1200 minus n. So there's my differential, that the change in the number of Ewoks related to time, dt, is directly proportional to this 1200 minus n. And I'm just going to solve this. We know how to solve this. We're going to bring the 1200 minus n over. So I go 1 over 1200 minus n dn equals k dt. And I'm going to integrate this. We know how to do this. Over here on the right, we get kt plus c1. On the left, be very careful. We do have a u substitution here, and I would highly encourage you guys to show this. So we get du equals negative dn. So dn is negative du. It's that negative I want. Remember, this is our u here. So when I take the antiderivative, it's 1 over u, which gives me the natural log of 1200 minus n. But don't forget, we have that minus on the outside. What I'm going to do next is kind of a neat little algebra trick. Divide everything by negative. So I get the natural log of 1200 minus n equals. Now, what's funny happens when I divide by a negative, that k is a constant. So it just stays a constant. You can put negative k if you like, but that's okay. You don't have to. So I get kt plus c2. And now we're going to exponentiate both sides. Natural logs e cancel here. I get the 1200, absolute value of 1200 minus n equals e to the kt plus c2. You have to show getting rid of the exponential. Simplifying that. Absolute value of 1200 minus n equals e to the kt times e to the c2. You have to show that step. Very important. But now we do that because that's a constant. I know that's a constant. So we're going to let e to the c2 equals c3. And now when I rewrite my equation, we get this absolute value of 1200 minus n equals c3 e to the kt. And there it is. Pretty. Whoops, let me get my light back on here. There we go. Sorry about that. That just happens sometimes. So when I take the absolute value, we can get 1200 minus n equals plus or minus c3 e to the kt. And this is our general equation. What we're going to do now, though, is we're going to solve for the constants, the c and the k. So to do that, we're going to go back to this initial constant, the initial values. I'm going to go make a table here. And I want you guys to do the same. Make a table. T and n. And when t equals 0, we know the population is 300. 4 years later, it doubles to 600. So what we're going to do now is use these to solve them. I'm going to use the first one. This is actually going to solve for c. If I use the 0, 300, I get actually going to solve for c because that's my initial condition when t equals 0. So I'm going to go ahead and find c3 here by using that condition. When t is 0, n is 300. Plug it in. We get 900 equals. Now, we're talking about a positive n, so I want the positive c. So c3e to the 0. c3 therefore is 900. So my equation so far is this. 1200 minus n equals 900 e to the kt. But now what we have to do is find k. Now to find k, I'm going to use my other condition. The 600. There's my t, there's my n. Plugging it in, plug it into your new one, I get 1200 minus 600, and that gives me 600 equals 900 e to the 4k. And I'm going to divide. I get 2/3 equals e to the 4k. Take the natural log of both sides. We have 4k, and I can solve for k. And I'm going to use my calculator for this. Go to about 4 decimal places here. Doc B, clear it out, clear my memory. I already kind of have it there if you saw that. We get the natural log of 2 over 3, and I'm going to divide that by 4. I hit enter, and I get this negative 0.1014, and there's K. So our equation is as follows. Our equation then is this: 1200 minus n equals 900 e to the negative 0.1014 t. And there is our equation. Now the last thing they want me to do is take the limit as t goes to infinity of n of t. Well, to do that, let's kind of think about this. If t goes to infinity, we're going to let t get really big. Then if t gets really big, remember this is a really big negative number and a power, this side, the whole right side, goes to 0. Then the 900 e to the whatever, that goes to 0. So what I'm left with is this 1200 minus n equals 0, so n equals 1200. So at the end of time, there's only going to be 1200 Ewoks here. Alright, our last question right here talks about Newton's law of cooling, okay? Calls about Newton's law of cooling. And it says the rate of change of the temperature of an object is proportional to the difference between the temperature of the object and the temperature of the surrounding medium. All I know of this one is that they give me a derivative. So I'm going to write that out. But before I do that, I need some variables. I'm going to let y equal the temperature of the object. The temperature of the object here. And I'm going to let x equal the temperature of the medium. The air, the water, whatever it's in, your body, okay? And t, of course, is going to be time. So what they're telling us is Newton's law of cooling. So we know that the rate of change of the temperature of the object, so the change of the temperature of the object with relation to time, is proportional, so K times the difference between the temperature of the object and the temperature of the surrounding medium. So y minus x. There's my differential equation. And now we're going to use this to solve our problem right here. It says, suppose a room is kept at a temperature of 60 degrees. There's our surrounding medium. There's x. So I can now rewrite this as dy dt equals k y minus 60. So there's my differential right there. And an object is cooled from 100 degrees to 90 degrees in 10 minutes. So right now what are they giving us is some conditions. And then how long will it take for it to decrease to 80 degrees? So off to the side here, I'm going to write down some ideas here, some information. Time and temp, or y. Time and y. So at time equals 0, I know the temperature is 100 degrees. 10 minutes later, I know it's 90 degrees. What we want to know is how long will it be for it to be 80 degrees. We'll come back to all this stuff in just a moment. But before we can do that, we must solve for y. Solve for y. To do that, bring this over. I get 1 over y minus 60 dy equals k dt. When we take the antiderivatives now, which we're going to do, on the right side we get kt plus c1 just like before. Over here there's a u substitution. Again, I would encourage you to write this out. U equals y minus 60, du equals dy, dy just du, which is what I want, no sign change. But remember, that's my u, so we're going to get the natural log of y minus 60 here. Exponentiate, pause if you need to. Exponentiate, we get the absolute value of y minus 60 equals e to the kt plus c1. In other words, so now when I solve this here, I'm going keep going here. I go absolute value of y minus 60 equals e to the kt times e to the c1. Let e to the c1 equal c2. You have to show that step. So we're going to get the absolute value of y minus 60 equals e to the kt times c2. Of course, we normally write that in front. So when I rewrite my answer, get rid of the absolute values. Y minus 60 equals 60 equals plus or minus c2 e to the kt. There's our general solution. Now we got to find C and K. So to do that, to find C2, I use my initial condition, C2. 0, 100. Plugging it in, remember this is T and there's Y. So if I plug it in, we're going to get 40 equals, again, I want positive Y, so I'm going to pick the positive C2, e to the 0. So C2 is 40. So right now our equation is as follows. Y minus 60 equals 40 e to the kt. Now we're going to find K. To find K, use the condition 1090. Again, there's T and there's Y. Plugging it in, 90 minus 60, I get 30 equals 40. E, be careful, there's my T, to the 10K. So I divide. What's that? 3/4 equals E, to the 10K, sorry, E to the 10K. Take the natural log of both sides, and I get 10 to the K. Whoops, sorry. I get 10K, not 10 to the K. Dividing it, use your calculator, go out about 4 decimal places. You know how to do this. I take the natural log of 3/4, and I divide that by 10. And we get negative 0.0288. There's our K value. So my equation, y minus 60 equals 40 e to the negative 0.0288 t. But we're still not done. We want to know how much longer will it be for it to be at 80 degrees. So now we're going to let y equal 80, and we are going to find t. So if we do that, we get 20 equals 40 e to the negative 0.0288 t. And dividing it, so that 1/2 equals e to the negative 0.0288 t. Solving it, take the natural log of both sides, and that's just going to become negative 0.0288 t. And let's see what we get here for time. If I take the natural log of 0.5 and I divide that by negative 0.02, negative, got my negative, 0.0288, I hit enter, and we get about 0.07 minutes. Now, but you got to be really careful. A lot of people think, oh yeah, there's my time for it, right? But be careful, it's already been 10 minutes, right? So how much, this is a line from the beginning, so how much longer is what we want to find. How much longer, I take my 24.07, I minus the 10 minutes from here, my 10 minutes. And we get, it'll be another 14.07 minutes before Mr. Wernow can drink his coffee. Alright, watch this video as many times as you can, okay? You will have a question like this on your final. I promise you guys that, okay? I'll see you guys tomorrow. Bye.